Example 2. Consider a car moving along a straight horizontal road with a speed of 72 km per hour. If the coefficient of static friction between the road and tire is 0.5, then find the shortest distance in which the car can be stopped. So consider the car was moving on a straight horizontal rough road. So obviously friction acts backward direction, means friction always against to the relative motion between the surfaces, and initial velocity of the car is 72 km per hour, which is equivalent to 20 meter per second, and the coefficient of friction is 0.5. So during the motion, the weight always acts downward direction and normal reaction acts upward direction. And since there is no motion in the upward direction, so normal always balances its weight. And at certain point of time, the car will be stopped due to the frictional force which is acting against to its motion. So final velocity of the car becomes 0. So the point here is how far the car have traveled before it comes to rest. So this problem can be solved by using work energy theorem. So according to work energy theorem, change in kinetic energy is equivalent to work done. That means final kinetic energy minus initial kinetic energy is always equivalent to the work done. Since the final velocity of the car is 0, that means final kinetic energy of the car becomes 0 minus initial kinetic energy of the car is half m u square is equal to, here work done is by friction. Since friction always acts backward direction to the motion of the car and the displacement of the car is in the forward direction, so work done will be negative. So minus Fs. So we need to calculate displacement here. So minus minus get cancelled. So half m, u is 20 meter per second. So 20 square will be 400 is equal to, friction is equal to mu into n. So n is nothing but mg into displacement. Get cancelled. 2 ones are 2 200s are. So what we get here now, 200 is equal to mu is 0.5 and g is 10 into displacement. So 0.5 into 10 will be 5, and if we send that 5 to the other side, so what we'll get, displacement is equal to 200 by 5, which is equivalent to 40 meters.